All right. Hi, guys, and welcome to the last class that we are going to have today for O levels. So, tomorrow is your MCQ paper. I hope you guys are excited and also confident ahead of the paper. Your paper is also going to be over soon, but that's no reason for us to slack off now. So, what we're doing today is it's basically an open query session. So, if you guys have any problems of your own, you can ask. Any question that you want me to go over, we can go over right now. There's also some stuff that I would like to talk about, and we'll also do that. So that's how we plan to take this session forwards. All right. So the first thing is tips in general for attempting MCQs. So this is stuff that I have talked about the entire year as well when talking about the MCQ paper. But again, it's just reiterating all of that stuff once again. So you guys don't make any of these mistakes in your paper tomorrow. For MCQs, I feel like it makes the most sense to attempt the paper in order, exactly the order in which it is given, because it naturally takes you through the paper from an easier topic and then to a more difficult one, and then it builds up. And in my opinion, electricity and magnetism is some of the most difficult topics. And then again with nuclear physics and space physics, which are relatively easier, that's how the paper ends, right? So this is a good thing to do, in my opinion, which is to attempt the paper in order, not just to flip through the pages and keep doing questions which just seem right to you. Just do it in the correct order. We also know this, that you have approximately 1.5 minutes per question. Again, this is just an average figure. So no need to actually time yourself, but this is just for you to have a feel of the amount of time that you must be spending on every question. Some of the questions, as you might have also seen when doing the yearly MCQs, is that some of these are very, very easy and you can just tick off some of these. For example, like definitions or just asking about units and stuff like that, or any sort of law or any sort of principle. So that's very easy to do. And then some other questions which are maybe more calculation intensive may take more time as well. So on average, this is the amount of time that you are supposed to spend. And for some questions, it might be more, it might be less. Keeping in mind this thing that you can have harder questions as well, it is going to be the case. And again, there's nothing you can do to get rid of the harder questions. If you ever do get stuck in a hard question, keep in mind that if you are finding this difficult and if you are not a below average student, and by below average, I also mean like really, really bad at O-level physics. And let's say if you haven't done any prep at all, which again, I don't think there is anybody like this who's watching this video. But if you have some prep and if you're like an average student, so you will be running into a problem. Keep in mind that other students will also be facing the same problem. So on a harder question, don't obsess over it. Go forward and complete the paper and then come back to it. So let's say that we have an average figure of spending 1.5 minutes per question, right? So we have an average of 1.5 minutes. Let's say you give that difficult question twice that time. So let's say you give it a good 3 or maybe even 4 minutes. I don't recommend 4, but let's say you give it 3 minutes and you still can't figure it out. You shouldn't get obsessed with it. You shouldn't fixate on it. You should go forward, complete the rest of the paper, and then come back to it. And let's say if you come back to it and if you still find you can't do it, then use the process of elimination, which you guys have seen me using from day one, which is to strike out some options which you feel are definitely not the case. And then you take a guess. Do not leave anything, any question tomorrow empty, no matter how hard it is. Take a guess, right? If you leave it, you are definitely getting no marks there. But if you take a guess, you could get some marks. So don't leave it empty. And again, candidates who do leave it empty, it's basically because of time management. So time management is super important, right? So if you follow it, if you follow these steps, so you will always be able to get a really good grade. So that's it about like the general tips about attempting the paper. Now for the different topics, I'll just be talking about some questions which could possibly come up. So a few of these questions, let's say like one or two, is definitely going to be scalar vector calculations. And could have to do with units or something, right? Could also be one of those questions where you have, which is basically the choice of instruments. For example, what do you use to measure the length of a wire and the diameter of a wire? So that sort of a thing. So remember questions like these we've done. So the first couple of questions are going to be those. Then we are going to have some questions, maybe like two, which are going to deal with the basic ideas of kinematics. Or if you are slightly unlucky, then you could also have a kinematics graph popping up. But again, it's not really luck, it's rather skill. And I believe that all of you, at least who have studied kinematics graphs from me, are now skilled enough to know exactly how you go ahead tackling that, right? So kinematics and some graphs, and then you could also have something regarding free fall. So do keep in mind that we have had questions. There was this one question off the top of my head in a very recent IGCSE paper. I think it was summer or March 23, in which it was said that something is falling and at time t equals to 0, when it is dropped, the acceleration was 3.8 meters per second square. And then after it has fallen some height, let's say 2 seconds later, what is the acceleration? And the catch was that it was falling in vacuum. So if it's falling in vacuum, this means there is no air resistance. So acceleration is constant because the only force which acts is the weight of the object, right? So for example, in this case, the answer was just 3.8 again. So you'll have something related to kinematics, something related to free fall. And again, you might have space for just one more question here. So that's going to make the first 6 questions. Then you are going to have some more questions. These are going to be related to forces. So one of these could be simply Newton's second law. And again, we have done questions like these, which is basically showing some forces marked and you might be given the mass and you're supposed to find out the acceleration. Let me show you the type of question I'm talking about here. This is, for example, the March 24 paper, the solution to which is uploaded. Oh, so this is IG. Let's find an O-level paper. For example, this question, if you remember, a question like this that we did in the last class. So something like this related to Newton's second law. If I remember correctly, and I might still have your, actually, let me just open that up. The structured question that you guys gave, that paper that you guys gave. So that's going to give me an even better idea of what could possibly come up. Yeah, it's this one. All right. So you have in your paper two, you were tested on density, but you weren't tested at all on mass weight. So definitely there's going to be some questions related to mass weight here. And we have done a lot of these in the topical worksheets as well. Also in the yearly papers, we went through some of these mass weight questions. Let's see if we can find any of those here. For example, a question like this. On Earth, a spring stretches by 5 cm when a mass of 3 kg is suspended. Small g is 1/6 of that on Earth. Which mass on the moon would stretch the spring by the same extension? So you know that extension is produced by force, not by mass. So if I find the force, basically the weight because of this 3 kg object, so that's just mg. So that would be 3 times 9.8, right? So now we have this as the force, which is so 3 times 9.8, which is 29.4. So for this to have the same extension, the same force would also be applied. The only problem here is this, that now small g is 1/6 of what it is on Earth, right? So if I write out the equation now for the moon, so this is the weight I want. Mass is what I need to find, and small g is 1/6 of what it was, right? So you just cross multiply here, and you will get the answer for the mass, which is going to be 80. So this is just an example question. You guys might also remember one of these questions that we did on the in one of these sessions, which basically involved a question in which this was some difference of weights. Let's see if I can find that. Oh, it's not here. Maybe it's this one. Let's see. You know, questions like these, which you do have a habit of doing, mass weight questions. There was just this other question in which it was said that the mass of something is this much, the weight of something, the weight of an object on Mars was this much, the weight of an object on, so small g on Earth, small g on Mars was given, and you were told that basically the difference between the weights is this much. So you just had to use W equals mg individually for both of the planets and calculate the masses. And then you had to subtract to find the mass of the object. You were given the difference of weights. So that is mg minus mg for the Earth and Mars. And then you had to use that equation to find out the mass of the object. So a question related to mass weight is definitely going to be on there. Also, there is nothing related to circular motion which was asked, right? So we can also definitely have a question related to circular motion. So I think that the examiner could go a bit heavy on the forces part here, because if I am correct, then the only forces thing which was really asked in your paper two was the question related to momentum, right? Everything else was not really linked to forces. It was waves and light, and then some electrostatics as well. But there wasn't really the part on forces, right? Which we usually expect. So you could also have circular motion. You could also have something related to stopping, thinking, braking distances. Stopping, thinking, braking distances, right? So you might be asked to, for example, make a judgment, or you might be asked to just have a simple MCQ about what affects what, How would these thinking braking distances change when these factors change? That sort of a thing. So yeah, so that's what you can expect. What else here? So you have had circular motion. You can also have something on, yeah, so you can also have something on terminal velocity. Do make sure that you know the idea of the falling parachutist as well. That's also something which has not been asked for a long time, so it might be asked this time out. For the falling parachutist, remember that we drew a very, very detailed graph. I'll just quickly show you what that graph looked like. It's going to refresh your memory. So this one, if you guys remember, so initially this is the speed time graph of a falling parachutist. Initially, it falls with acceleration due to gravity. This is the initial gradient. And then because of air resistance increasing, the resultant force decreases and hence acceleration decreases, which is why the gradient decreases. And when the air resistance equals the weight, the force and the acceleration become zero. So we reach the first terminal velocity. And then this is often asked that what is the point where the parachute is open? So it's this one where the speed just starts to fall. And for that time, air resistance is much greater than the weight. So basically, if something is falling, if air resistance, the upward force is greater, so it's going to cause a deceleration because air resistance, the upward force being greater than the weight means that the acceleration would be upwards while it's falling downwards. So that's really deceleration, right? That's how we explained it. And then because it's slowing down, air resistance decreases again to a point where air resistance equals weight again. That's when the second terminal velocity is reached. And then this continues until it hits the ground. So this thing about terminal velocity, that entire journey, finding the terminal velocity from a graph, we've also done a question like that in recent times. I'll just show you that question. Actually, it wasn't even all that long ago. So this wasn't really terminal velocity, but again, finding the graph, using the kinematics graph to find out the speed. So this was a distance time graph. So the gradient was the speed. So this sort of a thing. It's kind of a mix between the kinematics graphs and the terminal velocity thing. So this, and yeah. So that's some type of questions that the examiner can ask related to forces. All right, now let's take a small namaz break, and then we'll get back and discuss the rest of these MCQs.